right, this is the construct understanding portion on page 530. You can try this question before you watch this video. We've talked about most of this already. And then check back to see if you got it right. So here we go. We have the graph of y equals 1/2 sine of 2x, and then it progresses to y equals 1/2 sine of 2 with a phase shift, x minus pi over 4. And then the last function, 1/2 sine 2x minus 4 minus 3. There are 4 changes that are being taken place on the sine graph. So to help you with this procedure, we've got a chart at the bottom of the page that allows you to identify some characteristics. Okay, so I'm going to fill this chart out first. And we'll start with this first one, sine of 2x. Sine of 2x, so for that one, you know that that's a horizontal compression with that b value of 2 by 1/2. And over here, we have a vertical compression by 1/2 and a horizontal compression by 1/2. So the period of a typical sine graph we know is 2 pi. If we're going to horizontally compress it, it becomes half of that, a pi. The amplitude does not change. The amplitude is typically 1 for a sine graph, and if we're changing the horizontal compression, the amplitude stays the same. The domain is still going to be all reals. The range is still going to be every y value between 1 and -1. So y is bigger than or equal to -1 and less than or equal to 1. The phase shift is 0. We are not shifting a sine graph if we're compressing it by 1/2. And the zeros. Well, where are the zeros typically for the sine graph? Well, the sine graph typically has zeros. Think of your unit circle. These zeros occur at, where's y 0? Y is 0 at 0, pi, 2 pi, etc. Okay, so for sine of 2x, what happens with a horizontal compression? Aren't the x-intercepts also multiplied by 1/2? That is correct. 0 times 1/2 is still 0. Pi times 1/2 is pi over 2. 2 pi times 1/2 is pi, etc. So the zeros occur at x equals pi over 2 plus k pi. Or we could just say pi over 2 k, where k is an integer. That will take care of all multiples of pi over 2. The next one is the same horizontal compression, but now a vertical compression by 1/2 as well. So the period will still be a pi with that horizontal compression. The amplitude is now not 1, but 1/2 of 1 with that 1/2 value. So 1/2 of 1 is 1/2. The domain is still x is an element of the reals. The range, since the amplitude has been affected with that vertical compression, y is now greater than or equal to -1/2 and less than or equal to +1/2. The phase shift, there still is not 1 because there's no c value. And the zeros, well, we've already changed the zeros to reflect that horizontal compression. Here, the vertical compression does not affect your x-intercepts. So we'll say once again, x equals pi over 2 k, where k is an integer. Okay, continue on to 1/2 sine 2x minus pi over 4. So I'll just put these in here quickly now. Period is still pi. Amplitude is still 1/2. Domain is reals. The range is still between -1/2 and 1/2. But now we have a phase shift because of the c value here. That's a shift to the right, pi over 4. So we say pi over 4 is the phase shift. And the zeros are going to be changed because, don't forget, we're moving the entire graph pi over 4 to the right. Okay, so you'll notice on the last one, we said the zeros were multiples of pi over 2, k, where k was an integer. Well, what do we get when we add a fourth to a half? 1/2 plus a fourth, just writing down here at the bottom, isn't that the same as 2/4 plus 1/4? You're right. 3 pi over 4 would now be an x-intercept to 0. And the values where that would also occur would be plus or minus 5 pi over 4, 7 pi over 4, etc. Okay, I'll just list a few of them. The last one is the same as the one we just did, except now we're also going to incorporate a vertical shift down 3. We have a d value. So the period stays the same. The amplitude is 1/2. Still elements of the reals. Range, though. Now, this range from before, this negative 1/2 to 1/2, now goes down 3. What's 3 less than negative 1/2? Over on scrap paper, what's negative 1/2 subtract 3? Negative 1/2 subtract 6/2? That is negative 7/2. Y must be greater than or equal to that. And what's 1/2 take away 3? Well, that's negative 5/2. The phase shift is still pi over 4. And x-intercepts. Well, look at the range. The range takes us from negative 3.5 to negative 2.5. Well, the graph doesn't cross the x-axis anymore, so there are no x-intercepts. So you can use that information to establish the graphs. Okay? So let's go through a couple of these. 1/2 sine of 2x. Let's look at that one first. Okay. So instead of using a table of values approach for this one, I'm going to use a graphical approach. I find the table of values approach may be a little bit more accurate, but I'll do table of values for the rest of the examples today. Here, notice that the red graph is our parent function sine of x. So if we take the parent graph of sine of x, pick a few points, you'll notice that this sine of 2x graph is a horizontal compression by 1/2. So all of these major points must be restated as 1/2 of the x value. So for example, here x is pi over 2 at this point, so that would compress to this point. This x-intercept at pi is now an x-intercept at pi over 2. So the blue graph will represent all x values being halved. Notice that this graph goes through 2 cycles, 1, 2, for our typical 1. It's got half the period. The next one, 1/2 sine of 2x minus pi over 4. Well, that should be the same blue graph shifted right pi over 4. Let's see how that looks. The blue graph shifted right. My smartboard's playing tricks on me. We'll get this to work out. Here we go. Okay. So I've drawn this graph in red. 1/2 sine of 2x. Okay, well that's the one before the phase shift to pi over 4. That's fine. There you have it. The y values have been halved as well. And we still have that blue graph up on the screen to compare it with. Okay, so that blue graph is sine of 2x. The red graph is 1/2 sine of 2x. And then the next one here in blue is 1/2 sine of 2x minus pi over 4. And then in green, we have last one, which is 1/2 sine of 2x minus pi over 4 minus 3. Okay, so basically the first graph of sine of 2x takes on 4 shifts to become this green graph. Hope you like that. It just gets better from here.